in our next section, you need to be able to find the exact zeros in simplest form, whether they are real or non-real, and you need to be able to find them both algebraically and with technology. So here we go. Find the complex zeros. Just quickly reviewing this vocabulary, complex numbers. Well, part of the complex numbers are real numbers. Part of complex numbers are non-real numbers. But this set takes care of both real and non-real numbers. They're called the complex numbers. Alright, so find the complex zeros of this function. What can we then conclude about the x-intercepts? So here we go. We have the function x plus 7 quantity squared plus 18. And there's two ways. This is actually a pretty simple function. I recognize right off the bat that the vertex, this is in vertex form, the vertex is at -7, 18. So here's a little scale. Here's our vertex, there's our turning point. I also notice that our a value is positive. It's an invisible 1 here. It's positive, so therefore the parabola opens upwards. So something like this. Even sketching this tells me something. Tells me it doesn't have any x-intercepts. Therefore, this has non-real zeros. Automatically, right from the graph, I know this has non-real zeros because this parabola never crosses the x-axis. Interesting. So let's do it algebraically. What should happen algebraically if you have non-real zeros? Well, our zeros should be non-real. Let's check it out. A zero, by definition, is an input value that outputs a 0. So we set the output to 0 and then solve this. Alright, recalling how to solve this equation, when we have something in this form, in vertex form, we can strictly work backwards. Start with a number, add 7, then square it, then add 18. So we can work backwards, subtract 18 on both sides. This isn't so bad. And on the left we have -18. On the right we're left with x plus 7 quantity squared. The next thing we have x plus 7 then squared. We take the square root of both sides to undo the squaring. We are in algebra, so remember your plus and minus value there. Those undo each other. We're left with x plus 7 on the right, and on the left, well, I think this, well, let me be honest, I know this simplifies, but for right now I'm just gonna write it as such, and I think these parentheses aren't necessary anymore. There's nothing to group, so don't really need to write those. Last, x plus 7, undo this by minusing 7 from both sides. And I'm just going to write my answer over here. So I have -7 plus and minus the square root of -18. That's it. That's the solution. Not simplified, but this is the non-real zeros, right? So let's simplify because we need to be able to put our answer in simplest form. Second, almost like a separate little process here. How do we simplify square roots? Factor this. Well, I'm going to call this 9 times -1 times 2. You should know exactly why I'm writing it as 9 times -1. And if you don't, here's why. Square root of 9 is 3. Plus or minus the square root of -1 is I. And therefore we're left with the square root of 2 inside, which does not simplify, and we're done. These are our non-real zeros. -7 plus 3i times the square root of 2, and -7 minus 3i times the square root of 2. I didn't ask you to do this in this question, and I decided I'm going to do this right now. Let's check that. Let's check one of those zeros super fast. So the function was f of x plus 7 quantity squared plus 18. I want to check one of the zeros. If I input its value, I need this here, -7. So I'll check one of the, oops, -7 plus 3i square roots of 2. So input -7 plus 3i square roots of 2. Just barely made it in there. Let's see if this actually outputs a 0. Alright, so order of operations, start within our parentheses, -7 and +7 make 0. So one thing at a time. I have still 3 times I times the square root of 2, which needs to be squared. Then add 18. And 3 times I times the square root of 2. Properties of exponents here. We multiply each of these factors by this exponent, or we raise it to that power. So 3 squared is 9. I squared, oh, I love I squared. And the square root of 2 times itself is the square root of 2 squared. And square root of 2 squared is just 2. So that all is times 2. Whoa, too many dots there. Alright, so times 2, and then plus 18. Alright, I think we have it. Because I squared is -1. So 9 times -1 times 2 plus 18. -9, -18 plus 18 is 0. Yes, our answer checks. So I leave it to you to check the minus value, but it still works out. So there you have it. The zeros graphically are, if we think of this in terms of a graph, the graph does not cross the x-axis, so therefore we have non-real zeros. Algebraically, we work backwards and we get a non-real number, a complex number. These are our exact simplified complex solutions. Any questions, feel free to email me. Good luck.